Good day, students. Welcome to our clip on half-angle identities. So let's go ahead and write down the instruction for the two examples we're going to consider. Actually, this is just for number one. So for number one, I'm going to find the exact value of sine theta over 2, cosine theta over 2, and tan theta over 2. If cosecant theta equals 8 over 3, and theta is between negative 270. So we have negative 270 degrees is less than theta, and theta is less than negative 180. All right, so to find all these trig functions, if you remember the formulas, you notice that the formula for the half-angle identity for sine, let's write that down on the side here. For sine, alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. So this one needs only cosine. The one for cosine, alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. This needs only cosine also. For tan alpha over 2, we have three choices, but in this example, I'm going to be using sine theta, or I'm sorry, sine alpha. I'm going to be using sine alpha divided by 1 plus cosine alpha. Okay? So this one requires sine and cosine. So in order to be able to find all these three, we need to know what sine and cosine are. All right? So now let's figure out what we need. So we know that cosecant theta is 8 over 3. So if cosecant theta is 8 over 3, that follows that sine theta equals, because sine is the reciprocal of cosecant, so sine theta is going to be 3 over 8. All right? Now we have one component down. Now we need to find our cosine. So how do we find cosine? We use the variation of the Pythagorean identity. Cosine theta equals plus or minus the square root of 1 minus sine squared theta. All right? So let's put that in here. We're going to have cosine theta equals plus or minus the square root of 1 minus 3 over 8 squared, since that's the value of sine theta. All right, let's go ahead and reduce this, simplify it. So I have the square root of 1 over 1 minus 9 over 64, squaring the numerator and denominator. So that becomes plus or minus the square root of 64 over 64 minus 9 over 64. So when we subtract the numerators, we'll have plus or minus the square root of 64 minus 9 is 55 over 64. I'll take the square root of the numerator. We have plus or minus root 55 over the square root of the denominator is 8. So the question is cosine theta positive or negative? Well, we have to look at the quadrant that theta resides in, right? So let's make our coordinate system. Check that up a little bit. So put our coordinate system right here. All right, so we're going from negative 270 to negative 180. So this is 0. Since it's negative, we're going to be going counterclockwise. So 0, negative 90. Keep on going, negative 180. That's the upper bound, and negative 270 is the lower bound. Okay, so we're going to be in this quadrant right here, quadrant 2. So we know that all students take calculus. So this means that sine and its reciprocal cosecant are positive. Everything else is negative. So in this problem, cosine theta is going to be negative root 55 over 8. Okay? All right, now we have sine and cosine. Sine is 3 over 8. Let's write that over here. Sine theta from up here is 3 over 8. And cosine theta is negative root 55 over 8. Now these are the ingredients I need to create all the trig functions I need. Okay, so for part A, we need sine alpha over 2. Sine alpha over 2, what's theta in this problem? Sine theta over 2, and let's see. Yes, we're using theta here. Okay, so sine theta over 2, let's write out the formula first before we use it. So sine theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Okay, let's plug in the value. We have plus or minus the square root of 1 minus cosine theta is negative root 55 over 8. So negative root 55 over 8 divided by 2. Okay, simplify further, we have plus or minus the square root of 1 over 1. You multiply these two signs, plus root 55 over 8 over 2. This becomes plus or minus the square root of 8 over 8 plus 8 over 8 plus root 55 over 8 divided by 2. Combine the numerator, we'll have plus or minus the square root of 8 plus root 55 over 8 divided by 2 over 1. Okay, now we'll drop, change, flip. We'll flip the denominator. We'll drop the numerator, multiply by the reciprocal of the denominator. That's what division is, multiplying the reciprocal. So we have 8 plus root 55 over 8 times, we reciprocate this, 1 over 2. Okay, so when I multiply across, we're going to have plus or minus the square root of 8 plus root 55 over 16. Okay, now we're going to separate the square root to the numerator and the denominator, so we have plus or minus the square root of 8 plus root 55 over root 16. The square root of 16 is simply 4. Alright, so the question is sine theta over 2 positive or negative? Now remember, this one right here, this angle is for theta, okay? It's not for theta over 2. We need to draw a separate one for theta over 2. In the original problem, we know that theta is between negative 270 and negative 180. So where do you think theta over 2 is going to reside? So we divide everything by 2 because we're looking for theta over 2. So divide theta by 2, divide 270 by 2, and then divide 180 by 2. All right. So if we go ahead and carry out the division, we'll find out that we have theta over 2 in the center as less than, when you divide 180 by 2, we'll have negative 90 degrees. And then if you divide 270 by 2, you have negative 135. Okay? And we know for a certainty that negative 135 is bigger than 180, right? So we know that we're guaranteed that negative 180, theta is going to be greater than negative 180, and theta is going to be less than negative 90. All right? So what quadrant is this going to be? So let's draw our coordinate system. And then we have 0, negative 90, and negative 180. So we are in quadrant number 3. Okay? So we know that all students take calculus. And in quadrant 3, only tan and cotangent are positive. So that means that this is for theta over 2, sine alpha over 2 is going to be negative in this quadrant. Okay? So sine theta over 2 equals negative root 8 plus root 55 divided by 4. All right? Okay, now let's go ahead and take a look at question, the B part. which is cosine theta over 2. All right, so for cosine theta over 2, let's write down the formula first. Cosine theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. Okay, and that becomes plus or minus the square root of 1 plus, what is cosine theta? Let's go up here. Cosine theta is negative root 55 over 8, so we're going to plug that in. So we have plus negative root 55 over 8, that divided by 2. So we'll have plus or minus the square root of 1 minus root 55 over 8. So this is a fraction, I'll write it as 1 over 1 over 2 over 1. So that becomes plus or minus the square root. Oh, it's too big. Erase that. Make it a little bit smaller. So let's see. Plus or minus the square root of 8 over 8 minus root 55 over 8 divided by 2 over 1. Okay, so let's go ahead and combine the numerator into 1. We'll have plus or minus the square root of 8 minus root 55 over 8 divided by 2 over 1. Alright, so we're now going to multiply the numerator by the reciprocal of the denominator. So we'll have 8 minus root 55 over 8 multiplied by 1 over 2. Okay, so that yields plus or minus the square root of 8 minus root 55 over 16. Okay, now we'll divide the square root to the top and the bottom. We'll have plus or minus the square root of 8 minus root 55 divided by the square root of 16 is just 4. Alright, so is it going to be positive or negative? We're still in the same quadrant here. We're still in quadrant 3. So we know it's t, only tan and cotangent are positive, so we do not have a match. Hence, cosine theta over 2 is going to be negative root 8 minus root 55 over 4. Alright, so there goes your answer for cosine theta over 2. Let's take a look at the C part, which is tan theta over 2. So for tan theta over 2, we're going to be using one of the variations of the half angle identity for tan, which is sine theta over 1 plus cosine theta. Alright, so let's plug in the values of sine theta and cosine theta that we had before. So we have 3 over 8 divided by 1 plus, and then cosine theta is negative root 55 over 8. Alright, so that's going to give us 3 over 8 over 1 minus root 55 over 8. So put this 1 over 1. So we're going to have 3 over 8 over, express this as 8 over 8 minus root 55 over 8. Okay, now we're going to combine the denominator. The denominator is going to become 3 over 8 over 8 minus root 55 over 8. Now we're going to multiply the numerator by the reciprocal of the denominator. 3 over 8 times reciprocate the denominator, 8 over 8 minus root 55. So we have the 8's dividing out. So we'll have 3 over 8 minus root 55. Okay, now we're going to have a square root in the denominator, so we're going to multiply the numerator and the denominator by the conjugate of the denominator, which is 8 plus root 55, top and bottom, 8 plus root 55. And then that's going to give us, in the numerator, if we distribute this 3 to both of them, we'll have 24 plus 3 root 55. And in the denominator, we're going to have 8 times 8 is 64, plus 8 root 55, minus 8 root 55, minus root 55 squared, which is just 55, because the square roots cancel out. Okay, Notice the middle term cancel out since they're opposites. And we have 64 minus 55 in the denominator. So this becomes 24 plus 3 root 55 over 9. Okay? So we can divide the numerator and the denominator by 9. There's a common factor. So divide this whole thing by, by 3. Because 3 goes into 3 here, it goes into 24, and 3 also goes into 9. So tan's reduced form is going to become 8 plus root 55 over 3. Okay, so this is a value of tan theta over 2. All right, let's go ahead and take a look at question number 2. For question 2, we're going to find, number 2, find the exact value of cosine of, actually let's do sine, the exact value of sine 15 degrees using the half angle identities. Okay, now note that this same problem can be done using the sum of difference identity, right? I can express this as 45 minus 30, and then I can use the difference identity for sine to do it. But in this problem, we are instructed specifically to use the half angle identity to find out what sine 15 degrees is, okay? So let's go ahead and do that. So if you're using the half angle identity, what we'll do first is set alpha over 2 to the angle, which is 15 degrees, okay? If I double this angle, hopefully I get an angle that's on the unit circle. So what I'll do is double the angle, multiply both sides by 2, by 2, and then we have alpha equals 30 degrees. So this is what I'm going to plug into my formula, all right? So we have sine alpha over 2. The formula is plus or minus the square root of 1 minus cosine alpha over 2, okay? So we're going to plug in the numbers now. So we're going to have sine 15 is equal to sine 30 over 2, which equals plus or minus the square root of 1 minus cosine alpha. Alpha is 30 degrees, cosine 30 over 2. Okay. All right. So what is cosine 30? The value cosine 30. If you we can do this using a unit circle. If you look at 30 degrees on your unit circle, you'll notice that the x coordinate is root 3 over 2, and the y coordinate is 1/2. Recall that the x coordinate is your cosine and your y coordinate is your sine. So this basically tells me that cosine 30 is root 3 over 2. All right, so let's go ahead and input that in here. So we're going to have plus or minus the square root of 1 minus root 3 over 2 over 2. Okay, so let's express this as a fraction. So we're going to have, it's going to become plus or minus the square root of 2 over 2 minus root 3 over 2 over 2 over 1. Okay, so now let's unify the numerator. It becomes plus or minus the square root of 2 minus root 3 over 2 over 2 over 1. Now we're going to multiply the numerator by the reciprocal of the denominator. Okay, so it becomes 2 minus root 3 over 2 times 1 over 2. Okay, so now we have plus or minus the square root of 2 minus root 3 over 4. Now what we're going to do is separate the square root into the top and the bottom. So we're going to have plus or minus the square root of 2 minus root 3, and then the square root of 4 is 2. All right, so the question now is it positive or negative? To answer that, we need to identify where 15 degrees is located, and then we'll use all students take calculus to determine the sign of the trig function. Okay, so we have 0, too small, 90 degrees too big, 15 degrees is located here in quadrant 1. We know that all students take calculus. A basically means that all 6 trig functions are positive, so we have a match here. Sine is included in the A. Okay, so that means that sine 15 degrees is basically the square root of 2 minus root 3 over 2. Alright, so there goes your final answer. Box that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. If you like this video, you can click like. Please post a comment. Let me know what you think about this clip. More videos coming from mathcoachserve.com. Thanks again and have a wonderful day.